Guys, welcome back to my channel. So today we'll be solving physics paper 1 of May June 2025, and the code is 1-2, variant 2 basically. Okay, so let's start. Right. Let's start. Question number 1. Which list contains only vector quantities? Okay, first of all, we need to know what does vector mean. So vector is basically quantity which has magnitude and direction. So let's check all the options. First is mass. It does have a magnitude. But it does not have any direction. So this option is eliminated. Second is momentum. Okay, it does have a magnitude and a direction. Okay. Gravitational field strength. It also has a magnitude and a direction. Displacement. Displacement also has a magnitude and direction. So this would be the correct option. Option B. But we can check the other options as well. Energy is an um energy has magnitude only, not directions. It could also be eliminated. Acceleration has magnitude and direction both, but time only has magnitude. So this option will be also eliminated. Okay, moving on towards the next question. Okay, so the diagram shows the distance time graph for moving object. Let's change the color. This is on the y-axis and the time is on the x-axis. What is a description of the moving object? Here, the graph is divided into two parts. Okay. First is this part. This part. Where the gradient is constant. Okay. And part. This part, the gradient y is basically, what does the gradient of distance time graph tell us? What does it tell us? So basically, gradient is equals to y upon x, right? So y is distance, d, x is time, and distance upon time is equals to speed. So basically, the gradient is telling us the change in speed, right? Okay. So let's just look at the options. What are they telling us? Ball thrown vertically upwards and falling back to the floor. Let's measure it. This is the ground. Ground. Person is here who has thrown the ball upwards. Upwards. So the ball will reach a maximum height. Okay, this is the maximum height. Nothing is at edge. Maximum height. What will happen here? At this point, speed equals to be zero. Right? Speed would be zero. which means the gradient of this distance time graph should be also zero. So is it zero? Yes. This point at the green point in the color speed I'm denoting it as equals to zero. Okay, got this point. But here they are saying a ball is thrown vertically upwards and falling back to it. Would have been falling back. So the speed would have been increasing. But here we can see that the graph is ending at speed is equals to zero. This can't be correct. Okay, a car starting from west and speeding up as it moves away from a traffic signal. Car starts from west, okay? Alright. Speeding up as it moves away from the signal. Does this tell us, does this yellow segment tell us that the speed is increasing? No. Does this green segment tell us any such thing? Where the speed is zero? How is that possible? No, this is also incorrect. Right. A rock dropped from a high cliff falling into the sea below. Right. Let's imagine this. In the sea, the cliff. Person is here standing, throws a rock. Okay. What should happen? The speed should increase. Is it happening here in the graph? Is the speed increasing? No. M is basically speed. Speed is decreasing. No. So this is not possible as well. A train braking to a halt as it stops at a station. Okay. Braking and halt. Stops at the station. I should imagine this. The train track, the station. Train is a broken train. Train applies brakes. Brakes are applied here. So when brakes are applied, what happens? Speed decreases. Yes. The graph shows that shows us that speed is decreasing. The yellow part shows us that speed is decreasing. The green part tells us that speed is equals to zero, which means the moving object has stopped. Okay. This agrees. This agrees with the option D. The graph is coinciding. The graph is aligned with option D. That's the correct option. Okay. Now, question number 3. Okay, so here they are asking us. We just, yeah, zoom it out a bit. The speed time graph for a falling skydiver is shown. As he falls, the skydiver spreads out his arms and legs and then opens his parachute. Which part of the graph shows the skydiver falling with terminal velocity? Alright, first of all, to answer this question, you need to know what does terminal velocity mean. So I'm just gonna tell you the basic meaning of terminal velocity, okay? What terminal velocity basically means, right? It means constant velocity, constant velocity, right? At this point, So here, if you have no idea what's happening here, you need to just identify where velocity is constant. Yeah, let's apply this, basic concept. Then I'll, explain it to you in detail. Yeah. Here, speed is on the y-axis, time is on the x-axis. This is a speed time graph as it's mentioned in the question. So here we can see the speed is, it's decreasing. Decreasing. Here it's the slope is also decreasing. Here you can see there's a drastic decrease in the speed. Here the speed decreases drastically and then reaches a then it reaches a constant value. Okay. So here the speed is increasing but at a decreasing rate. And A and B are, somehow the same they are the same, they are one segment. You can't separate them. A and B is one single segment, then C is another segment here, segment of the graph, and then D, right? So if we just directly look, if we just, like basic concept, we need to find where the velocity is constant. So here, why? Because the gradient is constant, which means that the velocity is constant. Okay. Now let's get into the depth of the CLA segment is on terminal velocity. Okay. Now let's get into the depth of this concept of terminal velocity. So basically what happens is I'm gonna do some annotations here. Basically what happens here is that, for example, in this case the skydiver is falling. So what happens as soon as the skydiver jumps out of the plane, it's moving downwards. The skydiver is moving downwards. Okay, the skydiver is moving downwards. Okay, so basically terminal velocity is a real life scenario. Okay, we here all the resistive forces are acting in the body. 40, the skydiver is falling with a acceleration of 9.8 this G. 9.8. Okay. As soon as the skydiver jumps, this is the acceleration. But as soon as it, after some time, as the skydiver is moving downwards, resistive forces, which is basically in this case, air resistance, acts in the opposite direction. Resistive forces always act in the opposite direction, whether they are friction, whether they are air resistance, or any other resistive force. The resistive forces always act in the opposite direction. Okay, got the point? So, resistive forces, let me change the color, start acting in the opposite direction. I'm gonna resistive force start acting in the opposite direction. So, the net force, the net acceleration of the body will be lower than G. So acceleration will be less than G, right? And here the skydiver spreads out his legs and say when skydiver spreads out his hand, arms, and legs, what happens? Surface area of the skydiver increases. Now, for example, he spreads out his legs like this and like his hand like this. No, and like this, he spreads out his hands and legs. So what happens now? The surface area is increased, due to which the resistive forces will increase. Resistive forces acting on it will, on the skydiver will increase. That is why acceleration would become lesser. The acceleration would decrease, which means the speed time graph. You know that the gradient of speed time graph of acceleration. So here you can see in the blue segment, the gradient is decreasing, right? It's decreasing, which means the acceleration is decreasing. Why? Because the skydiver, spreads out his arms and legs. But when the skydiver opens the parachute, what happens? When the skydiver opens his parachute, again, this is the parachute. When he opens the parachute, what happens? The surface area increases more. Furthermore, the surface area increases drastically, due to which acceleration decreases drastically. Here you can see that in the green segment, the acceleration is decreasing. Okay, and after all this has happened, the skydiver reaches a point where he is moving with constant velocity, and that velocity is called as terminal velocity. Got the point? That velocity is called terminal velocity. At this point, acceleration equals to zero because constant velocity. Acceleration is rate of change of velocity when velocity isn't changing. So, yes, correct. If velocity isn't changing, acceleration will be zero. Good. And also, no net force is acting on the body. But so all the detailed concept, I hope you got the point of terminal velocity, what it means, and like the whole process, how it's achieved, all the details. Okay. So the correct option is D, as I have marked it earlier. Now, when you have understood the entire process, entire reasoning behind terminal velocity, I hope you'll be able to solve any question related to terminal velocity easily. Got it? Let's move towards the next question. Okay, the next question is, okay, the next question is that a car driver traveling at constant speed in a straight line sees a hazard in the road ahead at time equals to 0. Okay, so the speed time graph shows how the speed of the car changes from time equals to 0. All right, let's focus on the graph. Okay, so basically at time t equals to 0, hazard is seen. And this compare to here. This is the time taken by the driver to react. This is the reaction time, or let's say the thinking time. After that, this green region, which is also written as y here, is the breaking, is the distance uh, after the which car came to a halt. Is the distance traveled after braking. Okay. So this is, we could call it the braking distance. Okay. Now we have dissected the graph. Okay. Three students suggest what area X and area Y represent. Student one. Okay. So the student one is saying that area X represents the sinking distance, correct? Student 2, area Y represents the stopping distance. Look, stopping distance, what is stopping distance? It's basically the, you could say, sum of thinking distance plus braking distance. Is that so? No, because area y is the braking distance, not stopping distance. Area x plus y would have been the stopping distance, right? And yeah, as the student 3 is saying that area x plus area y represents the stopping distance, statement is correct. So, who is correct then? Which students are correct? Pardon me? Option B is correct. Okay, the diagram shows a graph of load against extension for material, at which point is the limit of proportionality. So basically, force and extension are directly proportional to each other. And F equals to Kx. K is the proportionality constant. Proportionality constant. Right? So basically, F over X equals to K equals F. So we know that for directly proportional quantities, the constant for them is a straight line passing through the origin. Here, the line passing through the origin, which is straight, is A. Because after that, it starts to bend, and then kind of a wavy kind of shape occurs. So A is the correct answer. Question number 6. There is no atmosphere on the moon. Okay. Two metal spheres of identical volume but different mass are at rest at the same height above the ground on the moon. The two spheres are dropped at the same time. How do these spheres move after they are dropped? So basically, we have to understand one thing here. What does it mean by no atmosphere on the moon? It means no resistive forces act on body. One thing. The other thing is, if, for instance, if there would have been a atmosphere existing on the moon. So, and they're saying two metal spheres of identical volume but different masses. Volume is same but masses are different. So sphere 1, sphere 2, M1, M2. So if just if in if case, okay, if there would have been atmosphere on the moon, So would it be dependent on the masses of the falling objects? So the answer is no. Very good. No. Why? Let me explain that. So the resistive forces acting on a body, if the body is falling like downwards, the resistive forces will act in the opposite direction. The resistive forces do not depend on mass. But what? They depend on what? Surface area. Good. They depend on the surface area. Here they are saying that the two metal spheres have identical volume. The volume is same, but masses are different. So different masses doesn't mean that they would have a different acceleration, or the heavier would reach the ground first or the lighter would reach the ground first. No. Different masses have no concern uh with the time taken, or with which acceleration they'll be reaching the ground. It depends on what? It depends on the surface area. So how do these spheres move after they are dropped? Sphere with the larger mass has small acceleration. As I told you, does not depend on mass. A sphere with the larger mass hits the ground first. Nope. Spheres with the smaller mass, the two spheres hit the ground together. This is correct. Right. A student determines the density of a small rock. The weight of the small rock is 1.2 Newton. She pours 100 centimeter cube of water into a measuring cylinder. She carefully submerges the rock into the 100 centimeter cube of water. The new reading on the measuring cylinder is 147 centimeter cube. What is the density of the rock? All right. So density formula is mass and volume. So the easiest to find is the volume. How? As the volume of water originally is 100 centimeter cube, but when the rock is submerged, it increases to 147 centimeter. That means volume of rock is equals to 147 minus 100, which is equals to 7 centimeter cube. Okay, now the mass. So weight is equals to mass into G. Using this formula, we can calculate the mass. Weight is 1.2, G is equals to 9.8. So let me grab the calculator. 1.2 divided by 9.8 is equals to 0.1224. The unit of mass is kilogram. But in the options, not bunking. Option in the unit is Newton per centimeter cube. This is incorrect. Okay, gram per centimeter cube. Okay, Newton per centimeter cube. This is also incorrect. On the basis of unit, I'm eliminating the options. Okay, gram per centimeter. This would be the answer. Now, here you can see the answers are given in the unit gram per centimeter, which means I have to convert kilograms into grams. How? By multiplying it by 1000. So the mass would be 122.4, and the volume and less intensity, right? So volume would be where's the volume? Yeah, here. It's the volume. 47. Who calculated now? The answer I'm getting is 2.604. So this would be the right answer. Option D. A rock of mass 20 kilograms is traveling in space at a speed of 6 meters per second. What is its kinetic energy? All right. Formula for kinetic energy is K E to half m v square. Let's input the values. Half into mass is 20. Speed is 6 and square of speed. That would give us 10, and 10 into 6 square equals to 36. That would give us 360 joules. So do we have any V2? Option number C. Next question. Which row shows an advantage and a disadvantage of using nuclear fuel to generate electrical power? Advantage. Okay, look. Use the elimination method here. Is nuclear fuel a renewable energy source? No. So option C and D are directly does not produce carbon dioxide. Okay. Produces radioactivity. Yes. Only works in some weather conditions. No. So option A is correct. Okay. Which row gives the definition of work done in the unit of work done? Work done basically means work. Okay. So what's the formula of work? Work equals to force into displacement. Alright. This means that the unit would be the unit is joules, but it could also be based on the formula Newton into meter, which would be Newton meter. Here in the given options, you can see they have given Newton per meter. Newton per meter would be directly eliminated, so B and D are incorrect. True is correct. The energy transferred per unit time. It's power. Power is work done or energy, you could say, per unit time. For this power, so option C is correct. So guys, in this video, I'll just stop here, and we've done 10 questions in this video. In the rest of the questions, I'll be drawing in my next videos. So I hope all these 10 questions I was able to, explain you the, the concepts, the proper logics. I was able to, explain all why the other options are incorrect, why the correct one is correct. All the, confusion you might be facing while doing the questions by yourself. I hope I was able to resolve all those ambiguities, all those confusions. If not, you can ask me in the comments. And also, if you want me to solve, any paper you want me to solve, you can also comment below, and I'll make sure to solve it for you. And apart from that, do like, do share, and do subscribe my channel. And don't forget to click the bell icon for the latest uploaded videos. And stay tuned for my next video. Bye bye.